Assalamualaikum everyone. Welcome to Mathematics with Shahab Yaqub. Now, in today's video, we will be solving October-November 2021 paper of paper 6, which is S2, probability in starts 2. And this is the variant 62. So in this particular paper, I'll solve the whole paper, all the questions in detail. So everything is blank over here. We have to fill it up. We have to read the questions and then we'll get started. Now, first of all, let me write down the time. So the start time is 2:33 p.m. local time. And let me start with question number 1. So now question number 1, it says that the mass in kilogram of block of cheese sold in supermarket is denoted by the random variable m. The masses of random sample of 40 blocks are summarized, and this is the details of it. They always give n sigma m square in a normal question. The first part, calculate unbiased estimates of population mean and variance. Second part, the price P of a block of cheese of mass m is found using this formula. That's how the two variables are connected. Find estimates of the population mean and variance of P. So this is first question. So we started off at 2:33 and I took some time reading it out. Now, first of all, the data is from the sample. So I'll write m bar equals to sigma m over n. And variance for the variable m, that is sigma m square over n minus m bar square. That is the formula. Unbiased estimate of population mean is the same thing as sample mean. Unbiased estimate of population variance, it's n over n minus 1 sample variance. So now I have to use these two. So this is what we are looking for. So first of all, let me calculate m bar. So m bar, that is 20.50 divided by 40. Grab your calculator, evaluate. This comes out to be 0.5125, exact value. The variance, I'll write this thing as 110.7280, that is this value, divided by n, which is 40, minus m bar, which is 0.5125 square. Do not evaluate, leave it as it is. Now over here, unbiased estimate of population mean is the same thing as sample mean. Let me simplify it, 0.513 correct to 3 SF. And over here, unbiased estimate of population variance, this is 40, this is 40 minus 1, multiplying with this thing over here, just write it down. This is 10.7280 over 40 minus 0.5125 square, close the bracket. Use a calculator, evaluate, this comes out to be 0.0056859, which can be written as 0.00569, again correct to 3 significant figures. So it's necessary that you give the level of accuracy over here, over here. That is the answer for this thing. Now I'm doing the explanation, doing the narration, giving you the background, and then solving it out. Second part. Now, what is this part all about? This part is about linear combination, a very strange connection, development that they have done. A variable is expressed in terms of another variable. So let me write this thing over here, that expectation of P is expectation of 11m plus 0.50. That is expectation of 11m plus expectation of 0.50. Let me just double check everything. The voice has all got all clear. So now this is 11 times expectation of m plus 0.50. That is 11 times some value plus 0.50. What is this value? Use the unrounded 0.5125. So 0.5125. I'll use the calculator in a short while. And make sure to write all these equal signs over here. Similarly, variance of P, that is equals to variance of 11m plus 0.50. That is variance of 11m plus variance of 0.50. Variance of 11m is 11 squared times variance of m. That is, and this thing is 0. That is 121 into variance of m, which is 0.0056859. 0.0056859. And I'll be writing down the answer for this. So the first answer is this thing, 6.1375, 6.1375. And one other thing, since this is exact, I should not round it off. So let me just remove this thing because this was exact. So let me just write it like this. And over here, this is also exact. Leave it as it is. And 121 times this thing, that comes out to be 0.6883 significant figures. That's the answer for this part. And that's how this question is completed. So now it's 2:39. So question number 1, this is the ending time that I write down. So ending time. So question number 1, this is 2:39 p.m. Let's move on. Question number 2. It says Andy and Jessica are doing survey about musical preferences. So this is about musical preferences. They plan to choose a representative sample, an unbiased sample of 6 students from 256 students at the college. The first part, Andy suggests that they go to the music building during the lunch hour and choose 6 students at random from the students who are there. Give a reason why this method is unsatisfactory. So now there are different reasons. The first one is that during lunch hour, people would have gone for lunch. And it's not necessary that they are all lunching out in the music building. They have gone for lunch elsewhere. So the population size is small. The population size is small to select a sample. Also, 6 students from the college. And what about those people who are there during lunch hour? 6 students. They probably are friends. And since they are friends, they could have similar preferences. And it's not necessary that someone who's not taking music. So other people are excluded. Other people who are not in music building or not studying music, they are excluded. So these are some of the reasons, in my view, which will earn you this 1 mark over here. Now the next thing, something important, that is about this thing. This is called the method of random numbers. So random numbers to select a sample. Now there are 2 things over here. The first one, repetition of digits is not allowed. Why it's not allowed? Because you won't be choosing a person twice. And second thing, numbers outside of range are excluded. Number outside of range, that is discarded. And then there is one thing, which is this. The numbers are ranging from 1 to 256. So basically 001, 002, all the way till 256. So since this is a 3-digit number, so let's break these up in 3-digit format. If it was a 4-digit number, we would break it up in 4-digit format. So let me write this down. So I'll write 204 393 162 007 204 028 587 119 207 395. So basically what I've done is that 1, 2, 3, 4, 5 and alternately 1, 2, 3, 4, 5. That's how these numbers are broken. So let me focus a bit more on this. Basically what I did is that 204 and 162 and 204 and 587 and 207 like this. And this is 393 007 028 119 395. It's broken up like this. I have written it separately over here. So now this is all good, all clear. Now, if they ask me to choose 6, let me ignore this line for a second. Just choose 6. So I choose this person. That's part of the range 1 till 256. I'll discard this one. I'll choose this one. I'll choose this one. 204 is repeated. So this is outside. That's why it's discarded. So this is rule number 1. This is rule number 2. It's outside. That's why it's discarded. It's repeated. That is why this is discarded. 028. Yes, it can be included. 587. Again discarded, outside. 119. It can be chosen. 207, it can be chosen. 395, this is outside. So how many have I chosen? I have chosen 1, I have chosen 2, I have chosen 3. 204, 162, 7, that's already chosen. Now, which ones are left? 028, 119, and 207. So therefore, the answer is 028, 119, 207. So these are the ones that is now included over here. All good, all clear. So that's how this thing is done. So now this concept of random numbers, that is taught new to you people. So just acknowledge over here, random numbers sampling method. Just explain, is this all good, all clear? Just acknowledge it on your respective WhatsApp groups. Okay. So this is question number 2. We forgot to note down the time. I think it was 2:39 and now it's 2:45. So 2:39 and question 2, this is 2:45. So 2 questions are down. Let's move on. Question number 3. It says the probability that a certain spinner lands on red on any spin is P. Now make a habit of underlining things. The probability that a certain spinner lands on red on any spin is P. The spinner is spun 140 times and it lands on red 35 times. So that is the first paragraph. Now let's go to part A. What is part A? Find and approximate 96% confidence interval for P. So now what is confidence interval? This is confidence interval for population proportion. Confidence interval for population proportion. First of all, let me deal with 96%. So 96% is in the middle. And what else do you have? So this is 96%. That's right over here. This is 2% on this corner, 2% on the left. And keep in mind, it is always symmetric confidence interval that we calculate. Therefore, the Z value that we will read, that is for 98%. Check your tables. As far as I remember, Z for 98% is 2.054 or 2.055. That is also a very common value. So now this thing is calculated. We need proportion of success. Proportion of success, that is 35 over 140. Proportion of failure should be 1 minus PS, 1 minus 35 over 140. So this is 1/4 and this is 3/4. Or this is 0.25 exact, this is 0.75 exact. So we have the Z value, we have PS, we have QS, we have the N value, which is 140. Apply the formula PS plus minus Z square root PS QS over N. So this is 0.25 plus minus 2.054 square root. PS is 0.25, QS is 0.75 divided by 140. Now grab your calculators and evaluate and double check. So now let me use my calculator. So this is question number 2, and this comes out to be the lower limit is 0.175. Let me write it properly. This is 0.175 and the upper limit is 0.325. That is the answer for this particular part. That's how the approximate 96% confidence interval is done. The next one. Now, this is kind of basic probability knowledge. It says from 3 further experiments, Jack finds a 90% confidence interval, a 95% confidence interval, 99% confidence interval. Find the probability that exactly 2 of these confidence interval contain the true value of proportion. Now, when we calculate a confidence interval, 90% chance, it includes P. So there is a 90% chance of including P. There is a 10% chance of not. 95% including P, 5% not. 99% including P, 1% not. So now let me write 3 scenarios. That is A, that is B, that is C. And let me write down the options ABC, ABC, ABC. So basically, let me just space it out further so I can comfortably write it. So now over here. Okay. So let's say this is A. This is scenario A. This is event B. This is event C, just like basic probability. So now this is included. Yes, yes, not. Yes, not, yes, not, yes, yes. That is what we have to do. So yes is basically 90%, 95%, 99%. That is yes. So therefore, I'll write 0.90 into 0.95 into not, which is 1 minus 0.99. This is 0.90 into 1 minus 0.95 into 0.99. This is 1 minus 0.90 into 0.95 into 0.99. It's either this or this or this. So therefore, add it up, total it up. This answer comes out to be 0.147. So this is like a tree diagram, basic probability, S1 type of question that they have asked for 3 marks. So 1 mark for each step. So now this thing is done and now it's 251. So question number 3, that's done. This is 251. Let's move on. Question number 4. It says a certain kind of firework is supposed to last for 30 seconds. So certain kind of fireworks supposed to last for 30 seconds on average after it's lit. An inspector suspects that the fireworks actually last a shorter time than this on average. Now, on average, that's a common factor. So just ignore that. Now it says this thing, he takes a random sample of 100 fireworks. So now 100 fireworks are taken and it's a random sample. And then it says each firework in the sample is lit and the time it lasts is noted. Otherwise, how will you know the time that it will last? All good, all clear? Now, what comes to your mind? Is it normal? Is it binomial? Is it Poisson? What exactly comes in your mind? So I think what comes in your mind is that it should be a scenario of binomial. So that is the first thing that should come to your mind. But before that, what are they asking? They are asking, give a reason why it is necessary to take a sample rather than testing all the fireworks of this kind. We are not using the whole population, we are using a sample. Because if we use all fireworks, there won't be any left to use. Whether that use is about selling, that is for any other further events, future events. So there won't be anything left to use, anything left to sell. That's the first thing, a very basic question. It is given that the population standard deviation of the times that the firework of this kind lasts is 5 seconds. Now, I think maybe I've said that this is binomial. It's not binomial because the probability of success is not given. A sample value is given. The mean time lasted by the 100 fireworks in this sample is found to be 29 seconds. Test the inspector's suspicion at the 1% significance level. First of all, what is the distribution all about? X bar, it's a sampling scenario, follows a normal distribution. Mu is 30. Standard deviation is 5. So therefore, let me write 5 square divided by 100. That is the sample size. And the mean time, the sample mean, this is found to be 29 seconds. H naught, null hypothesis, H1, H naught, H1, and then the significance level. Significance level is 1%. That gives me a Z value of 2.326. You can check the table. I remember it. H naught, mu is 30. Inspector's suspicion is mu is less than 30. Now calculate Z. So let me draw a line in the middle. And let me also grab a normal distribution table right over here. And over here, since it's a lower tail test, so therefore it's a lower tail test, 1% significance level, this Z value, it goes over here. And this is negative 2.326. And over here, I'll calculate the Z value. Z is X bar minus mu sigma square over n under root. That is 29 minus 30 divided by 5 square over 100 square root. How much is the Z value coming out to be? This is coming out to be negative 2. Does this calculated Z value lies in the confidence interval? This is 0, so negative 2 lies on the outside. That is the Z calculated value. The Z calculated value does not lie in critical region or rejection region. Therefore, do not reject H naught, except H naught. We have insufficient evidence at 1% significance level to accept the inspector's claim. We don't have enough evidence that the mean is less than 30 seconds, and that is the suspicion of the inspector. We cannot accept this particular claim. Now, did it say in the question that it follows a normal distribution and we just took for granted? That is what the second part, the last part is all about. State with a reason whether CLT was needed. Yes, CLT was needed because it did not state, or it means the question did not state that it was following normal distribution. Since the sample size is large, we converted into normal, but originally it was not normal. So that is question 4, and that is done. And this is 258. Question 4, this is 258. So 4 questions are down. Now over here, question number 5. It says in a large document, typing errors occur at random and at a constant mean rate of 0.2 per page. Find the probability. There are fewer than 3 typing errors in 10 randomly chosen pages. What is this question all about? It's about Poisson distribution. These are the conditions. The mean number of occurrences occur at random. It occurs at a constant rate. It occurs singly. It occurs independently. All these things are there. Now, first of all, let's take 10, multiply it with 0.2. That comes out to be 2. So X follows a Poisson distribution with 2. Fewer than 3. Probability X is less than 3. That is probability X is lesser than or equal to 2, which is e raised to power of negative lambda. Lambda is the mean number of occurrences. 1 plus lambda power 1 over 1 factorial, lambda power 2 over 2 factorial. Grab your calculator. And this is coming out to be, so let me just grab my thing. This is which question? This is question number 5. So this is question number 5, and this comes out to be 0.677. 0.677, correct to 3 significant figures. The second part. Use an approximating distribution. Find the probability. There are more than 50 errors, typing errors, that is, in 200 randomly chosen pages. So now what will you do? So you will take 200 and you will multiply it with 0.2. So that comes out to be 40. X follows a Poisson distribution, and this is 40 over here. But since lambda is greater than 15, therefore X follows a Poisson normal. Poisson becomes normal. And this is 40, this is 40, because expectation of X is lambda, so is the variance of X. And now once you have this, you will write, they are asking for more than 50 errors, continuity correction. So let me first write 50 over here. Let me write 50.5. Let me write 49.5. Let me draw 2 number line, one in blue, one in green. And which is the proper one? Since probability X is greater than 50, it does not say it includes 50. So after continuity correction, it has to be the blue one. X is greater than 50.5. Probability Z is greater than 50.5 minus 40 divided by square root of 40. Probability Z is greater than some positive value. How much is this positive value? 1.660. 1.660, which is 1 minus probability Z is less than 1.660. 1 minus this value from the table, which you can grab, and this comes out to be 0.0485. 0.0485. That is the answer, correct to 3 significant figures. So now this thing is done. Question 5. No, there is also part 3. My bad. So now it says, in the same documents, formatting error occur at random at a constant mean rate of 0.3 per page. Find the probability. Total number of typing and formatting errors in 20 randomly pages is between 8 and 11. So we know that X follows a Poisson distribution with 0.2. Y follows a Poisson distribution with 0.3. This is typing errors. This is formatting errors. So total is x plus y. Total also follows a Poisson distribution with 0.5. Now this is per page. How many pages are there? 20. So 20 into 0.5, that comes out to be 10. So T follows a Poisson distribution with 10. Normal approximation is not there. This is basic. Between 8 and 11. Probability X lies between, let me write it like this, lies between 8 and 11. That is e raised to power of negative 10. 10 raised to power of 8 over 8 factorial, 10 raised to power of 9 over 9 factorial, 10 raised to power of 10 over 10 factorial, 10 raised to power of 11 over 11 factorial. Just double check if everything is correct. E raised to power of minus lambda, lambda raised to power of x over x factorial for 8, 9, 10, and 11. Double check, all good, all clear. So now let's evaluate. This comes out to be 0.477. This is 0.477. That is the answer for this particular part. So now this is 303. Question 5 is done. 303. Let's go back. Okay, now question number 6. Read through this particular question. What does it say? It says a machine is supposed to produce, let me change the color. A machine is supposed to produce random digits. Bob thinks that the machine is not fair. So Bob thinks machine is not fair. And that the probability of it producing the digit 0 is less than 1 over 10. Now, there are 10 random digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So probability of each has to be 1 over 10. Bob is thinking it has to be lesser. That's one approach. The other approach is whatever value is written over here, that is for alternative hypothesis. We'll use the same value for null hypothesis. H naught, probability of success is 1 over 10. By the way, this makes it binomial. X follows a binomial distribution, something comma something. H1P is lesser than 1 over 10. And in order to test this suspicion, he notes the number of times the digit 0 occurs in 30 digits produced by the machine. He carries out a test at the 10% significance level. And this time we have to find the rejection region for the test. So first of all, we will write 30, 0.1. So N is 30, P is 0.1, Q is 0.9, and this is something which is very, very important, which is new, that is finding the rejection region for the test. What we do is that this is the significance level for comparison. We calculate the probability starting with the lowest value of N, which is 0. Technically, it's R. So we use these probabilities, we use this data, we calculate 30C0, success raised to power of 0, failure raised to power of 30. This simplifies to 0.9 raised to power of 30. And let me grab the calculator. So now over here, this thing is coming out to be 0.0424. 0.0424. Let me quickly convert it into decimal, 4.24%. Let me also calculate probability X is equals to 1. That is 30C1. Success raised to power of 1, failure raised to power of 29. And this comes out to be 0.1413 or 14.13%. Now let's draw a number line. And this is 0. This is 1. Less than 0 is 4.24%. Less than 1 is 0 and 1. So probability X is less than or equal to 1. That is 4.24 plus 14.13. How much is that? That is 18.13%. 0.2737, 18.37%. So this is 18.37%. But the significance level is only 10%. So the significance level is somewhere over here. So we have this significance level. That is for like 10%. Only this value is giving me the right value. This value is exceeding it. So therefore, the critical region is x is equals to 0. What is this about? That means if it produces 0 times the value of 0, then this is the critical region. This is the rejection region. Anything more? Yes, Bob's suspicion is correct. State the probability of type 1 error. Probability of type 1 error is probability of the critical region. That is probability of x is equals to 0, which is 4.24% or 0.0424. That is the answer for this particular part. And now what does it say? It is now given that the machine actually produces 0 once in every 40 digits. On average, find the probability of type 2 error. So now you will write x follows a binomial distribution. Number of trials is the same. Probability of success has changed. So probability of success is 1 over 40. Probability of failure is 39 over 40. Now, this can be written as, okay, let us leave it in fractions. Probability of type 2 given the probability of success has changed. That is probability x is greater than or equal to 1. That is the rejection, the acceptance region. So now if we have a number line, if this is 0, this is the rejection region. So acceptance region is this thing. So naturally, it is dealing with integer. So this has to be greater than or equal to 1, which is 1 minus probability x is equals to 0, which is 1 minus 30C0. Success raised to power of 0, failure 39 over 40 raised to power of 30. Now, when we evaluate this thing, what is the answer? This comes out to be 0.532. 0.532, that is the answer for this particular part. Now, the next one, explain the meaning of type 2 error in this context. Now, type 1, reject H0 when H0 is true. Type 2, accept H0 when H0 is false. In other words, H1 is true. Now, if H1 is true, H1 as P is less than 10%. P is less than 0.1. We are accepting H0. We are making a mistake. So how should I write this thing in words? So in words, I write this thing as concluding that the probability is lesser than 10%. We are concluding probability is less than 10% when in reality it's not. This is the reality. This is what we are accepting. We are concluding, we are accepting the fact the probability is less than 10% when in reality it's not. That is the probability of type 2 error. All good, all clear? So now let me just check one thing. Okay. Let's move on. Question number 7. Now let me just pause for a second. So now let's continue. Now, what is this last question all about? The last question is about CRV. It says PDF, also known as PDF, probability density function of a random variable x is given by such and such. Kx4 minus x lies between 0 and 2, 0 otherwise. K is a constant, show that K is 3 over 16. That is the first basic part. So now what we do is that, first of all, we write this thing as K bracket 4x minus x squared. So if I integrate Ks outside, 4x minus x squared dx between the limits 0 and 2, that is the probability density function. The total probability is 1. So this is 4x squared over 2 minus x cubed over 3 between the limits 0 and 2 equals to 1. Plug in the upper limit. Let me make boxes. So over here, this is 2 1s are, 2 2s are. Let me plug in this. So this is 2 square minus 2 cube over 3. This is 0 minus 0. So this comes out to be K into 16 over 3 equals to 1. Therefore, make K the subject. Therefore, K is 3 over 16. That is the basic thing. Second part, find expectation of x. The formula for expectation is integrate between complete limits. X multiplies with fx dx. So if I multiply this with x, this becomes 4x squared minus x cubed. So expectation of x is 4x squared minus x cubed dx between the limits 0 and 2, and this is 3 over 16. So therefore, this is 3 over 16. Integrate, that is 4x cubed over 3 minus x power 4 over 4 between the limits 0 and 2. That is 3 over 16. This is 4 over 3, 2 cubed minus 2 power 4 over 4 minus 0 minus 0. The 0 is very, very helpful. So therefore, this answer is coming out to be, let me just go back to the calculator, and this thing is done. And this is coming out to be 5 over 4, 1.25. That is the answer for expected value, expectation. The random variable y has the following properties. This is very conceptual. Y takes the value between 0 and 5 only. The PDF of y is symmetrical. So what I'll do is that the sketch should be between 0 and 5. The shape does not make a difference. Symmetry makes a difference. So let me just draw a little bit of symmetry over here. Quadratics are symmetrical. Normal distribution is symmetrical. So I'm drawing it like this, just to give you this idea. It's symmetrical. That means, let me do one thing. The mean lies exactly at the middle. That is 2.5. That means this is 50%. This is 50%. That's the first thing. There is a value A. Probability y less than A is 0.2. So let me mark over here. This is A. And this probability is 20%. 0.2 is 20%. Now, if I transfer this thing to the other side, this difference is A, this difference is A. Therefore, this value would be 5 minus A. Make sense? This difference is A. So this value is 5 minus A. This is also 20%. And now let's focus on this y between 2.5 and 5 minus A. That is this thing. Y between 2.5 and 5 minus A is how much? Very simple. This has to be 30% because right of this line is 50%. 50 minus 20 gives me 30. That is for 3 marks. Very conceptual. And that completes the paper. And this is 318. So I think I skipped question 6 and question 7 altogether. That's 318. We started at 2:33. That is 27 minutes plus 18 minutes. How much is that? 27 plus 8? 35, 45, 45. So we took 45 minutes to complete a paper which is for 1 hour 15 minutes. I hope you would give me an A star for this, because that is a perfect time to do such a paper. Understand this thoroughly, jot it down, and stay tuned for more content on mathematics with Shahab Yaqub.